Hello explorers and welcome to another video. Today we are going to build Linux. So we are going to look at what Linux is and everything that has to do with Linux. So now we need to do the next installation here. So we will go back to our work directory. We will keep binutils because that might be something that we want to do later. We will do tar xf from mpfr. So that's something that we need to. And then we will do the same with, we will extract the GMP, and we will extract the MPC. So now we have extracted a lot of files in different directories. And it also wants us to move the different directories to shorter names. MPC to MPC. And we also want to move GMP to GMP. So now we have shorter names. A move is just a way to rename files directory or something. So MV stands for move. So now that we have done that, let's see here. To build that, this is complicated. The following command will change the location of the GCC default dynamic linker to use the installed tools, and also removes user include from GCC include search path. Unpack the packages into the GCC source directory and rename the resulting directories so the GCC procedure will automatically use them. Okay. So that's what we did. So we actually want to extract GCC as well in this directory. GCC is quite large, so that's why it took a while to do that. We didn't do any verbose on that. So then we will move the MPC. Here we will move the MPCFR, we will move the GMP over to this GCC directory. Here, so let's do a little bit of a script. Fix include. So when you create a script, you first want to tell it what to run this script under. So I do bin bash. So this is a bash script. We will do for all files in GCC config and then Linux or i386 or /Linux or 64.h. So for all different combinations you can find thereof, you want to do. And what you want to do is copy the file to something called original. So we want to make a copy. So we have the original file. Then we want to use sed. And sed is a simple editor that is not that simple. It can actually do a lot of interesting things. So it will change some paths here. 64. So this script is a little bit complicated and a little bit strange, but in a very simple way we can say that this goes through all the files in the configuration of your GCC and change your USR dir, where you usually find all the libraries and everything that is required to build your GCC. And then you will actually change that to tools directory, so it will build it into the tools directory, and also look for your bin utils in the tools directory instead. And you see here also that you had some standard start file prefix. We will change that to tools lib as well. So this is pretty much what this file is all about. So these here will change the library path, and this up here will change all the instances where you can find lib 64 or 32 and LD, and change all of those instances into tools. And it will do that in all the configuration files that has Linux, i36 Linux, or 64.h. So this is either Linux 64, i360, 386, Linux, or Linux 64. So it's 4 different files that we will change some values in. And down here you also do some more things to one of the files that we will actually change lib64 to lib, just to make compilation easier. So I have created that. I will do change mod x on this fix include file, so it's actually executable, and then run that. And it gave me an error. Let's look here. So I had some typos in this file, but I followed the guide that was written on in the documentation. So this is the final file where I've removed some of the character that I ended up writing in. And now I have run this include fix, so it has done all the changes. Then they recommend that you actually build GCC in its own directory. So I will create a build directory, and I will configure this build. And this configuration will be a lot of things. We need a target, and that target we already know. It should be LFS TGT. So that's the target. We prefix, we already know that one. It should be tools. Now comes the thing here. We need to specify a lot of things. We need to specify what glib version we want to use. So glib, and that's a very common tool. glibc is the library of all libraries. It contains all the Linux stuff. So glibc is very essential to Linux. It's a lot of functions and a lot of functionality is in libc. It's actually replaced with something called musl in Arch Linux, which is a very Alpine Linux, which is a very condensed Linux, where you want it to be as small as possible, because glibc is quite large, but it also have a heavy punch. It's really a really good library with a lot of good things in it. And then we will say which sysroot we will use again. So we are now trying to build our compiler here again. LFS. So that's our sysroot again. We will build it with new libraries. We will build it without headers. And headers are something you use in Linux to, when you have C files, you have header files that will give you the functionality of the C file. So that's kind of an interface for the C files, perhaps you can say. And then you do it with local. See if I can figure out what happens here. With a local prefix. The local prefix should be also our, or a local prefix should be the tools directory, and with native system header dir, and that should be tools include. Jesus. Then we should disable NLS again. So that's the command we used earlier. We should also disable shared. This switch forces GCC to link its internal library statically. We do this to avoid possible issues with the host system. So we want to build a compiler that is not using any of the system's shared libraries. We want to build something that is contained. And then we disable a lot of more things. We disable, let's see here, we disable, let's see if we can write in, disable multi-lib. We will disable decimal float, so no decimal floats. We'll disable threading. We will disable libatomic. We'll disable, so this list goes on here, lib gnomp. Disable libmpx. Disable, and I think that all of this that we disable here is just things that comes default to GCC that we don't need at the moment for this build, because this compiler is something that we want to use temporarily to build our system, and then we will build a compiler that will build the rest. So this is a temporary compiler that we are creating here. So it only needs the things required to build a compiler. So we build a compiler that is enabled to build a compiler. So we disable a lot of features that we don't need. Lib sdc cxx. We don't have the standard lib for C, C++, or something like that. Enable languages. So the only languages that we want to use is C and C++. So we don't want anything else than what's required to build this. So the switches that disable here will disable floating points, extensions, threading, libatomic, what we said before. These features will fail to compile when building a cross-compiler and are not necessary for the cross-compiling temporary libc. So that's why we disable all of them. Disable multi-lib is used just because we don't want to, when we build on this 64-bit system, we don't want to build something that can be either or. It doesn't really support that at the moment, so we will turn off that support. And we also just want the two languages, as I said. So now we will run this command here. I forgot disable for one of these. There was so many. Disable. So now we will run this. We made a make file, and now we will make, and this might take a while. So I will clip. So now that we have built GCC, we will make install that one like that. So we have a lot of binaries that we will put into our tools directory, but this is a temporary compiler for glibc. So when we did that, we now need to build the next package, and this is the Linux headers. We don't need the full Linux kernel. We just need the header files in order to later compile glibc. So let's extract the header files. So we have Linux. So this is the Linux kernel that I'm extracting now. Later on we will build the Linux kernel because we need that to actually boot the system. So this is the core of a Linux environment. This is what everything runs on. But at the moment we only need the headers because that's an interface to talk to the kernel. So in order to build the headers, we will go into the Linux kernel here. We will run make Mr. Proper, and that will prepare the Linux kernel. And then we will run make install hdr path. So that's the header path, and we say dest for that, and then headers install. So that will install all the headers from the Linux kernel into that directory. So it will copy a lot of headers into this dest directory. So here we have an include file with all the headers. We will copy that with the copy rv, so recursive verbose from include .star /star to tools /include. So now we have copied all the header files over to our include directory. So that's a start for that. So now we will build the glibc. Again, we need to extract glibc. So in this case, when we extract glibc, we actually saw that we had something more here. We have a patch file. So we need to apply this patch file. So we go into glibc, we will run the command patch-t, we will send the data from this patch file that we see in glibc, and then dash this patch file. So now we have applied that patch to the glibc in order to build it. So now we need to configure glibc. So we do a we need to create this build directory that we usually have, and then we will configure glibc, and we will configure it with a prefix. So this is the standard tools directory. We will add host. So this is this LFS target that we usually use. We want a build script for this. So let's see here, and it should be something like this. Config quest. So this is just to prepare it for the build. And we need to enable kernel 3.2 and later. So this is a flag to enable later kernels. I guess they had some point where they said that we will only build it for older kernels, but if you add this flag, we will build it for newer kernels. So I guess they had a breaking point somewhere where the API didn't match. We will use the headers from tools include, and we will also add two flags, libc-cv-forced unwind equal yes, and we also have libc-cv cv-c-cleanup equal yes. And these are to turn off some tests that will not be correct in this environment, because this environment has a GCC that is not, it's just temporary. So all tests might not be able to run. Some of them will fail. So when we run this, we now see that we actually are missing some executables here. It says that guac and bison, which is required to build glibc, is not available. So we will need to go down here and extract bison. Let's see, dash bison. And we also need to extract guac. And these are tools to handle different text data. So they are used in this build process, so we need to actually configure these. And we can make a build directory here as well. And these should be easily built here. We don't need to add that many extra parameters. I will find the actual builds for these. I believe we only need to say configure and then use prefix of /tools. And I believe bison has the same requirement. We don't need to add anything extra to bison either. So we will make that. I will look into bison as well. See if I can find bison. Bison, yeah, same goes for bison. So let's build. So guac is built. We will install that. It was fine to build that with our not so sophisticated GCC. We will make a build directory in the bison as well, and we will configure it with prefix /tools. And I follow the guide for all the builds here. And here we see that bison actually required M4. And so we need to extract and build that as well. So we will build M4. So all packages are depending on previous packages. But the good thing is that we don't actually need to... these packages are just built for the glibc at the moment, and we will rebuild them later in the real process. And if you had newer versions of these in your systems already, you weren't required to build them. This live Ubuntu CD seems to be missing these packages, and therefore I will build them. And this M4 actually required some extra things here, so I will type in a sed command to change some things in files here. We will change the try-lock file to io _end of file scene, and we will change that in all lib-c files. And start at C, and we'll also echo this define. They require an extra define statement here. See if I can. There we go. Define. So define is a way in C to we do _io_in backup. So defines are something that we define a specific variable in the file. So we will set the hex value of 100 into io in backup variable in lib standard io implementation h. So we'll add that there. And we will go into our build directory. We'll configure this with -- prefix tools. And those fixes were required to build this with glibc, this older version, but as we haven't built it, we will still build it with the glibc that is on our local system at the moment. But fine, this is what we need to do in order to get it up and running. So that's why we build it like this. So now we have built M4, we will build install, so we get that into our tools directory. We'll go back to Bison into our build directory. We will run our configure -- prefix tools again. And now the M4 should be available, so it should be able to configure Bison. So let's see if it works. It looks a little bit more promising here. It didn't fail that early. So let's see here. A lot of things to configure. And it configured. Let's make it. And Bison was built. So we also need to install that. So we have the Bison library installed, or the Bison files. So now we can go back to our glibc and try to configure that again and see if we have all the things necessary to build glibc. Because this was a little bit more of an involved build than all the other packages that I went through here. Those were quite easy, but here we see that we have a lot more configuring to do. But it seems that glibc is now configured, so now I will make glibc. Yes, and we're back. Now I have built glibc, and glibc is actually a very important package. It has all the requirements for the C language. So you have network handling, you have string interpretations, you have math, you have file open and close, and so on. So you have a lot of important things in glibc. So that's a package that you really need. In Alpine, another Linux distribution, they have replaced glibc with Muscle, which is a very much smaller package. But if you want to build C programs, you need glibc. So let's just install this package as well. It might take a little bit of time to install it because it's a lot of libraries as well. But now that we have built glibc, we have binutils, we have the C compiler, and we have the main C library, and this means that we can build C applications. So it would be good for us to actually test out that we can build a C program, a C library. So let's try that as soon as we have this installed here. We will build a small C program and see that it actually compiles and looks reasonable. In order to do that, we will do echo int main and then just brackets. So this is the smallest C program that you can build, I believe. So it just has a main function. And the main function does nothing, but it's still valid and something that you can call if you like. So we will take this LFS target, so LFS underscore target dash GCC, so that's our new compiler, and we will compile dummy C. Now we have done that, and when we've done that, we actually have this dummy C object file. And we also will have a file called a.out, and that's the actual binary that we built. So now we will do read elf to read the file information of a out, and in this we will grep is a command to look for something, so we will grep for /tools, so :/tools in this file. And here we see requesting program interpreter, and then we have a library in our tools directory lib64. So we actually have a program that is looking for things in our directory. So now we will remove all the dummy files. Those I will remove, and I will also remove this a out, because we don't need that in our build directory anymore. But we have seen that our C library actually works. I think I will break this video here. So this video will be a series with lots of different videos. I hope that you found this video interesting. I hope that you learned a little bit more about Linux, and I hope that you like this video. Give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. If you have any questions or comments, leave them in the comment section down below. And I really hope to see you in the next video.